Okay, welcome back to this video. Is a continuation of the last video where we learned about React optimization techniques. So in our last video we learned about list visualization, and we are able to come up with this code from our last class. And remember, the code was initially like this. So if we go to list visualization, you're going to notice that it was more than this. So if I remove this render and put this, so to show more list items, and that is where the list visualization comes. So it does not get to load all the list items just at once. So but what I want us to fix is this flickering that is here. How do we stop this thing from flickering like that? So it's still the same thing, so let's use the one that we used in our last class before we start the one for today's video. So the first thing I want to do first is, like I explained last time, the list visualization can be used when you have a list of tables or things to show, and there are so much, like 100 list items, 50 list items, 1000 list items. So that can significantly slow down your page load time. So but when you use list visualization, you can decide like 10 should show within a screen view, then as you use as 6 more, it will load the rest, thereby optimizing your page. But now we notice that this flickering happens. So let's fix that. The first thing I want to do is to go to where I'm calling this, which is in my car component. So go to your car component, go down. So I want to wrap this around a div, so I'll add a div. So in this div I want to add a mean height of 50 view height. Then perhaps I can add a margin Y of 4, so that if we go to our browser, so if I paste this tab, so that if I paste this, I go to my browser, I will see something that looks like this. So you notice I have something that looks like this. So I don't think that has affected mean height, so I think there is no minus here. So you see that there's a space here now, so you see the flickering again. So the next thing I want to do to fix that flickering is to go to the list visualization here. We need to add a padding X of 2 and a padding Y of 4. Then we also need to add the style attribute back. Style. So let's see how that goes. So now you notice that the flickering has stopped. So let's make this enjoyable by making this display inline instead of block. Now I remember from our last class on Sunday that we were able to learn how to customize our, or limit the way we type our tailwind classes, so we can reuse our tailwind classes. So I want to use this class then a flex between, so I extended the tailwind this way, so that each time I want to reuse something like this, I can easily use it instead of typing all this thing every time. So I compress them to one word. So you can use the principle to limit how you write so many tailwind classes. So let's go back to the render now. So here I'm going to put flex between. Remember, this doesn't exist in tailwind. I just customize it. So if I do that, I have something like this. So now you see how it looks like. So now you notice when you scroll to the down, there is no flickering again. So now this, so just imagine this list item, they are about 1000. So as you scroll, once you get to the last, it stop and there's no flickering again. So that was just a fix I wanted to highlight. So before I move to the business of today, which is lazy loading images. So similar to lazy visualization techniques, lazy loading images prevent the creation of unnecessary DOM nodes, thereby boosting performance. Lazy loading allows you to defer or delay the loading of images until they are needed or visible to the user, instead of loading all the images on page load. So this is similar to what the list visualization does. As many lists that can be showed within the view you specify, that is what it will load. So the remaining ones will be unloaded. So that is the same thing with this one. So if you have like 20 images in a page, once the user opens the page, the first view before a scroll contains like 3 images. So it's going to load only those 3. The rest 7 will be unloaded. But as the user scrolls down, it's going to load the images as needed. So how do we add this to our project? So we need to go to npm and type npm lazy load images. So let's do that. Let's learn how to use that. Let's learn how to use that documentation. So npm lazy load images. So go to this component here. So then we'll just copy this. So I'll highlight this. I think it refreshed. So I'll highlight this, do my Ctrl+C, go to my terminal. So I'll go to my terminal, open new terminal. So what I'm just going to do here is right click and paste, then I'll hit enter. Now I already have this installed, but it's just going to update in case there's a new one. So while it's loading, let us check the documentation. I think we need to refresh this. Okay, so we have that installed. Then now look at the example here. So we are going to create a component. Then you can, of course, this should be a reusable component so that we can easily reuse this instead of typing all this in all at once. So what I'm going to do now is to copy this, the whole of this, Ctrl+C. So I'll go to my React and create a new folder inside my component called lazy. Then inside it I'll save it as lazy image .jsx. So the installation is done, has been completed, so I'll close that terminal. So I want to change this, so Shift Alt Control Shift L to highlight all the occurrence, then save this as lazy can't get my X, lazy image. So then this is an object, that's why you have this dot here. So what I'm going to do here is if there is no auth, just use the default one. So if there's an auth, you use image dot auth, or if not, you use this one. You use just put image. I think there's an error here. That was what I was trying to look at. Okay, so that has disappeared. So the same thing again, the image height, if there's height, so image dot height, else we want this to be 400 pixel. Then of course this is very important, because you must pass a unique URL. So we don't, unless you want to have a default one, so I can actually do that, but that is important. So image dot width, else that should be 600 pixel. Then the caption, there's one, we have our image dot caption, else we have our, call it image caption. Okay, so this is how we will use our reusable component of lazy images. So I'll save this. Then the next thing I'm going to do is I'm going to go to my browser, look for some images. So I use swimming images. So I have this, so this is butterfly, or is it dolphin? Okay, so this has loaded. So what I'm going to do is to copy image address. Then next what I will do now is I'll come to my car.js, and under this I'm going to call my lazy image. So I'm going to call my lazy image. So if your IntelliSense doesn't show yours on time, you press Ctrl and spacebar, so that will load it much faster. Okay, so we have our sroc. Remember, sorry, excuse me. Remember, it's not just sroc. We passed it as an image. So this is an object. So it's going to be image. So you must use image Then this is an object which I can pass my sROC now. Then in quotes I'll paste my URL. Nice. So if I just to make this more visible, so I'm going to increase this height now to 70 so that I have to scroll to see this. Now if I go back to my browser, now as I scroll down, notice I have this here, but now you see only when I save this am I going to see this. Now look at the image caption here. So this is the default height. Now let me add another one. So I like this one. This one is front crawl, which is one of the hardest for me. So copy image address. So the next thing, I'm going to duplicate that. So I'll just duplicate this so that I don't have to type it again. So I'll just change the sROC and paste that. So let's look for another one. This time we want to add one at the top of the page. So the last one, I want to add it at the top of the page. Oops, I thought I copied everything. Control C. So whenever you are doing a project, this should not be done after you finish. Just make it as part of your coding habit. Then you find it easier to add optimization. So let's use this one. This one is just a dive into the water before the front crawl starts. So copy image address, then the sROC, I'm going to edit that, paste. So now if I save this, go to my, notice I'm seeing this image now. So this is the image. Now as I scroll down, see how the page is fast. Then I have this. Now see this one, you see, just in time. So you see that the page loads fast. Now if I refresh this page, you notice the image loaded faster. So that is it for your lazy loading of images. So the next time you want to optimize or from now on, once you're doing your project, always use this lazy loading image pattern. For now, there's an easier way I'll show you later on, but for now this is how you do your lazy loading of images. Okay, so we are done with lazy loading images. So the next one I want to go to is memoization. Now memoization in React is a technique used to optimize the performance of functional components by catching the result of expensive computation or function calls. It's particularly useful when dealing with computationally intensive or frequently called functions with the same input values, as it helps avoid redundant calculation and improve the overall efficiency of the application. So in React there are three techniques for memoization. We have the use memo, we have the memo, and we have the use callback. So let's begin with the first one, the React memo. Now one of the advantages of this is if a state does not change, don't rerun the function or recompute the value. So by limiting re-rendering, your React application will run a little bit faster, and that is what this tree method aims to do, as we'll see. So let's start with the first one. Use the memo. Now remember, I mentioned earlier in our class that when a use state gets updated, it causes a re-rendering. Now that re-rendering is React's way of updating the exact portion of the page that was updated. So, but it becomes a problem when you have a component that is called inside another component and you update the parent only to find that the child also updates when it's not meant to do that. So using the memo, we can tell React when to update the child and when not to update it. So let's do that. So I'll go to my we'll still use our car component. So what I'm going to do now is this. We already have a count here. So if we go back to our page, we have a count already. So here is our count. So add count, you see it's changing 5, 6. So I see. So what I want to do now is this. Let's go back to, and we have a child component. So I think I should remove this for now. So let's find out why. So what we want to do now is this. So let's go. This is our child component. So let's go back to our car component. So what I want to do now is, notice from here that we just have this our use count. Then we have this console.count that shows that the car rendered whenever we change the state. Then I think this page is clustered, so let's use a new page, the one that is less clustered. Let's see, this one is, so let's create a new component. So we have another one called parent. So inside this parent, I want to create a new one called parent.jsx. So I want to have my ROAFCE. Okay, so we have that. Then inside here now, I want to use this guy, this use count. So let me grab that. Can close this. So of course we'll have to import our use count here. Okay, that has been imported. Then we need a button. So what I'm just going to do here is Ctrl X, H2, that will be the parent title, then H arrow, then H3. So I have my count is equal to C. Then I'll have a button dot outline outline 1. Then I'm going to name this count plus plus. So we'll add an event listener here. So on click, we just have our increment. So how do we see this here? So let's go to our app.jss. So what we are going to do now is to call this below our nav. So we have our parent, so it's not coming forward, so space bar, control space, so that has come. Then we have this now. I'm just putting this here so that we just easily understand this instead of creating a new route or this, because it seems all the components we have done so much on them. So let's save this, so just to understand the principle and you can apply them in your project. So let's look at this. So to any page you go to, either blog or this, we'll be seeing them because this is called globally in the app. So let's leave it at this. So once I increase my count now 5, you see this is happening. See, this is happening. So what I want to do now is, in my parent component, I want to demonstrate that first, whenever there is a UseState update, there is a re-render. So we have our console.count, control space bar to easily bring out that. Then we have our parent rendered, so we have that. Then to our child, we have that the child rendered it. Okay, we already have that there. So let's look at that from our browser. So you see the parent rendered this. So if I update the parent, you see we have that. Nice. So let's now call the child into the parent. So let's look at the parent. So press your end key, we have that. Then I'll have a child, if it's wasting time, control space bar, we have that now. So if I save now, notice what we'll be seeing on our console. I will have the child render. So let me clear this. So if I, so you see the parent rendered 1, 2 child rendered, but whereas the child was not updated, like a state was not updated inside the child. So see this, see the parent rendered, the child rendered. So here is where we use our memo to decide when the child will render, even though the parent state is being updated. So to do that, we'll come to our child component, and you're going to return this as react.memo, then we'll wrap this here. So now that you have done this, so let's test this out. See, we're still getting the child render, so we have to refresh so that we have to pick up that. So now we have the first initial render, of course. So now notice the child does not get re-rendered when the parent update. So if we pass this count prop into the child, that is when the child will render. So now, for instance, let me create a new use state here. So let me do that. So I can come here and say let name set name then use state so I can set this to John Doe. So what I want to do now is this. I want to pass the name here as a prop to the child. So name, then I also create a button to update name. So shift alt arrow down. So in here I'm going to have my anonymous function set name I'll set that to Amadi Chile. So this is going to be set. So this is going to be update was not spec update name. So now you know from we've already done this before. Once I click on this button, I cannot re-update name again because the value didn't change, because it's still Amadi Chile that will be updated each time. It is not as dynamic as the count. So that means if I'm using this name here, so let's say something like this. So I have, let me cut this to my H to paste this here. Then let me make a paragraph. I'll say my parent name is, then I'm going to use my name. So let me destructure that from here. Name. So now we have this. So I'll save this and save this. Now just to give a space between the two buttons, so I'll do my margin left of 3. So that will give up. So that will create that space. So let's do that now. So I have this, my parent name is John Doe. Now you notice, just like it happened before, once I update the parent, you see the child does not get updated. But notice what happened when I update name. You see the child gets rendered, and you see that the name here changed to what? Changed to Amadi Chile. Now if I click on this again, you see, because the state does not get changed, you see the child does not get re-rendered. You see there's no change here. But if I update this now, you see, so that means if I pass this count as a prop to the child, then each time I press this button, then the child is also going to be rendered. So I hope with this we've understood how to optimize our application using the memo, especially when we are calling another component inside another. So like we have a component and you're calling another component inside, so we can optimize it by deciding when the child component will render, by making the child component be returned as this, as area.memo. So if we add this to all our chart components, then we'll be optimizing them. So another optimization technique of the memoization is this. We use the use memo. Now the use memo optimizes performance by memorizing the result of a function call or an expensive computation. It catches the result and recalculates only when the input value changes. So let's do this. So the example here is we already have this. So we'll create an array of prices. Then this is the function that will calculate the total. So we are using the array.reduce. Then we are going to now memorize it. Now before we actually do this, you notice that each time I update count, it's going to recalculate this even though the value will still remain the same. But by the time we add this use memo to return a memorized value, only when we put a dependency here, let's say each time that count reaches 10, then it should revalidate or recalculate this. Or each time a new item enters or the line changes, it should recalculate this. Only then will it recalculate this value, and therefore we will not be seeing this. We will not be seeing this console here. So let's actually do that. So we want to go to our parent container. Then let's have our array of prices. So let prices be equal to just random values 3, 40, 55, 70, 900, 300, 11 and 22. So we have this array of prices. So we want to write a function that will sum all of them. So function get total price. Now this can be dynamic, so you receive an array. Then when the array is received, so we want to return math dot, no, not this. We want to have an array as close and array dot reduce. Then we have our A, we have our B, and now we want to return A plus equal to B, so that will return a value for us of the maximum value that will pass. So now what I want to do here is let total price be equal to get total price. Then I will now pass my prices. So but in here we want to do our count again. So console.count, so I will know if the function was actually if the function actually ran, because if it recalculates this value, then this function will definitely run. So we'll say get total run. So what we want to do now, we want to actually display this on the DOM. So type symbol, say total price should be total price. So excuse me. So now I have this. So you notice that my total price will be showing me that is 1361, and if I like to add the dollar sign there, so it will show me $1,361. Now notice what happened when I change my count. You see, get total run, even though the value still remains the same. You see, so this is not, it is not optimized. So to optimize this now, we need to use our use memo to return a memoized value, so that only when this value change, like a dependency change, that is going to recalculate that, and that is what we have here. So we have our use memo, then we are going to add our anonymous function, then return this, so that only when we put a dependency here that this is going to run. So let's do that. So I'm going to cut this, use my use memo, so that will be automatically imported. Then my anonymous function, and I paste this here, then I put a comma, then my dependency array. So now if I do this, notice it's still the same value, but notice what will happen when I update my count now. So notice here it was showing me round total each time I click this, but let's see what happens. So you see, you notice the get total run did not run again. So it's actually optimizing our application. So what if I want it to run when I update this name? So we see the same thing. I'm going to now add it as a dependency here. So I'll just add my name here. So if I do that, only when name changes state, that is going to do that. So if I do that, you notice that it does not get recalculated, but when I update my name, you see the child, all those things that has name as their dependency run. But now if I do that again, you see nothing happens. So that is how we use our use memo. Now the last one that I want to learn about is the use callback. Now the use callback is similar, so the use memo and the use callback hooks are similar. The main difference is that use memo returns a memorized value and use callback returns a memorized function. So let's say I want to create a function that gets the maximum of, like the maximum price in the prices array. So let's say I want to pass that function to the child component. So I don't want it to always run when the parent updates. So I'm going to use that. I'm going to use my use callback. So in case I want to make the array or the function that I want to pass to the child component dynamic, I can pass that here. Then so this looks like this is an anonymous function inside the use callback. Then you have your console.count, then this, then you're going to return what you want to return, just the normal way we do that. So let's actually flesh this out. So first you're going to see what happens when we don't use the use callback. So let's say I have a function, so I'm going to use, so let's say I have a function, and that is I'll get my get max price, then I have the array, then now and now I want to get the max price, so I will return max. Then I'm going to use my spread operator dot array, but in case I didn't receive my array, I just use the prices so that it doesn't don't have an error. So what I'm going to do now is I'm going to send a prop here. So I'm going to say max price should be equal to this get max price. So remember, the use callback is used to memorize a function. So in my child component, just to avoid typo error, just copy this. It's always safe to take precaution instead of to spend time debugging your code. So I have this. So what I'm going to do here now is let user max be equal to max price. Then because it's a function, I'm going to invoke that. So I can put here, maybe a h6 here. Let's say user max price for this checkout was user max. Okay, so let's see what happens when we do this. So if I save this and I save this, but before we save this, let us get this to, so the console.count max price run. So let's see what happens when we update our parent container. So let's see. Max price is not a function. So let's see get max price. Everything seems correct, but let me just refresh. Max price is not a function. Try this for let me check. Let me comment. I was using don't have a child component here. Let's see if I'm using it somewhere else. I think that might be the error. Let me try refreshing. max child max 3. So let's see. Function I can't call this like this. It will just be a variable. See, that will not work. So I'm actually passing it as a function. Oh boy, so the error is not a function at this. Okay, let's troubleshoot. Okay, let me try the longest method. Is I have to invoke this here. Then I don't have to invoke this here, so I'll just put my max price. Okay. So this has worked. Let's see if when you refresh what. Okay, so that was how we fixed that one. Then this is not returning the max. So let's try to update this mass run, but we are not seeing this here. So let's see why we're not seeing it from our chat component. We have user max. Okay, it's showing here user max was 900. So it's showing here. I was looking at this, but it's showing in the chat component. Okay, so now we have that. So error is part of programming. So you encounter some errors, and the ability to fix them make you happy and a solid programmer. So now we have this, but notice that each time I update this now, you see the max price reruns even though the value is still the same. So, and you notice that the child component does not get re-rendered, but that function gets called from the parent from the parent component, and is not being rendered again because this guy is already doing this job. So what we want to use the use callback to do now is it will not run this function even from the parent from the parent component. So let's do that. So what I will do now is to get max price. I'm going to cut this out and I'll say use so what I will just do is just to convert this to an arrow function. So I will just put const get this should be equal to, then use callback. Then I'll grab the whole of this, Ctrl X, go inside this, then I'll paste that. So I've converted that to an arrow function. Then this need to be inside here. So that is how I convert that to an arrow function. But in case we wanted to use that our original one, I think this is still straightforward, because it is automatically just returning this. I tried using the normal function in my practice, but it didn't work. So let's see. So we'll not waste time. So I have this now. So let me update my account again. So let's see, let me refresh. Now as you guessed it, I missed one point. That point was I need to add a dependency array here. It should be empty. So if you don't add a dependency array, that means you want it to run just like normal. So let's see if that works. So let's refresh. The initial error we had, we're not supposed to invoke this here, you're supposed to pass it down. So let's see if the error will come back, because as long as we call it in that done for this one, then it's going to throw an error. So I think this is one. Let's see if it will work this time around. We are back with our error. Max price is not a function. So let's see, is there something that I did wrong? Price Okay, so max price ran twice, so I think we've done that. So actually what was happening was, you know, this child component can be a global I've used it somewhere else before. So since I did not, and I just don't know why it didn't work, but I think using this conditional rendering makes it to fix that error, because it only will run this function when it is available. So if it is not available, then it will not run the function, and therefore this one will show as undefined. So, and I believe that is why this other one in our browser here is not showing anything, but whereas this other one is showing something. So, and this component here is in the bottle, this one here. But if we go to the car now, I don't know why it's also displaying twice. So let's see, do we call it more than once? I think that would be an oversight. So this was the error here. I didn't see that, or this why. So this was the error, because we are calling it without passing that function. So only when I made it a conditional, so you see it's fixed now. So even when if I don't put this now, so if I remove this conditional rendering now, I don't think we'll have that error. So that was an error due to oversight. So you see it worked now. So now we get to understand how we can optimize our React application using the memo, the use memo, and the use callback. So that is that. So a lesson we just learned now is, when you're declaring a component that should be reusable, try to handle all your prop states, so that if they are not called, they should not, or if they are not passed, they should not be run, or just pass a default value. For example, even though I want to actually add this one, so let's say for example I want to add this one, like if I comment this add now, it will throw an error. But what I can do here, just to handle that error, I can put or, then I'll put an anonymous function, and just invoke that, something like that. Let's see. Let's see, or 0. So that error wasn't cleared. So I think the first way we clear that error was to do that. I think that was the best way we can do that. Just use it as conditional rendering. So we just use our max price, then and so if this is undefined, is not passed, it will not run this. Okay, so that is it. So you notice now that this other maximum price is not it's still the same thing, so it does not get recalculated. But notice what will happen. Of course we can remove this now, but notice what will happen when I add a dependency here say if the name is updated name. So you notice what will happen now. If I update my account, I get this, but notice what happens when I update my name. Now I see how many things run. The get total run, the max price run, so it then means it's actually working the way we want. So that is it for the memoization part. So the next one is code splitting. Now code splitting in React is a technique used to split a large JavaScript bundle into smaller manageable chunks. It helps improve performance by loading only the necessary code for a specific part of an application rather than loading the entire bundle up front. So this means that let's say our website has like 30 pages or like 30 routes, and the user just requests for the home page. And you know how React behaves. Once you request for the home page, it's as if it's bundling all the entire website to you, so that when you request for each of those routes, it can easily fetch it to you. But if we don't use code splitting, one of the disadvantages is that once a user requests for any of those pages using their route URL, it will try to load everything first before even showing the user that page, whereas the user just want to check only one page. So what code splitting will do is that it will lazy load other components. So it will just load only the components that you want to access. Then whenever you request the other ones, it will now load them as needed. So that way React becomes more faster. So this is how we do that. So import React, then you add your lazy and your suspense from React, then const dynamic component lazy load. Then we have this now, asynchronous components, then we have this also. So how we are going to do this now, apply this to our project, is this: we are going to make sure that all this our route page, we import them as lazy load component first. Then inside our suspense, we are not going to put our routes here. So this will be represented by our routes page. So let me show you that. So from our app.js here, we are going to do all these imports. So we'll say bye bye to automatic import, because automatic import does not do lazy loading for us unless you find that a VS Code extension that does that. Okay, so we are going to painstakingly import all these as lazy load components. Then we are now going to, then inside here we are now going to wrap this our routes inside our suspense, or we wrap this inside our suspense. So the benefit of, we are going to know if it's correct, is when we click on this page, or this page, it is going to show that loading small before to load the page, especially if it's a page that will actually fetch something from the backend or from a server. So let's begin to do that. So the first step we need to do is we are going to import this as a lazy load component. So I'm going to cut this route, Ctrl X, then you're going to put from say lazy, then we'll import this as a variable. So say const car equal to lazy control space bar, then we'll now have our routes here. I think we have our path here. So that is how we do that. So let's check if that is correct. So we have our lazy. Okay, I missed the import. Then this should be in quotes. Okay, so I'll look my Control Z, import, then okay, so that is how we do that. So let's cut this out, then I remove this, change this to const, then equal to lazy import, and I paste this. Okay, so let me duplicate this, then I'm going to change this to blog, Ctrl V, then I'm going to cut this, Ctrl X, Ctrl V. So I have that. So the next one will be my IT berries. Okay, so the next one will be my IT berries. I think I'm not using my IT berries, so there's no need for me to waste that time. Then we have our nav. So what I'll just do, shift alt arrow down, then I'll change here to nav, then I'll have to copy this, Ctrl C, and replace here. So I'm done with this now. Then this guy needs to go up, and this our import need to come down. So the next one is our error component. So shift alt arrow down. So this one will be my Ctrl X, Ctrl V, then I do my Ctrl X. So to get something right is usually is to take time. Sometimes it's not easy to do what is right. So now that we are trying to optimize this, you see how difficult it looks like, but it's actually the best when you think of the overall benefit. So I'll paste this, then to my Ctrl X. So this is another reason why this should be your coding habit, so that you don't have to do this after you have so many components installed. So many routes. So the next one is our login. So I'll cut this, Ctrl X, Ctrl V, Ctrl V, then this now, Ctrl X, Ctrl V. Okay, so the next thing that I want to do now, running our sign up. So I'll do my Shift Alt arrow down, Ctrl X, Ctrl V, then I'll just cut this out, Ctrl X, Ctrl V. Okay, so the next thing I want to do is to move this and duplicate this, so that this will be my use state. Ctrl X, Ctrl V, then I need to cut this out, Ctrl X, and Ctrl V. Finally, it looks like it's remaining 2. Okay, so I'll do my Ctrl X, Ctrl V, and Ctrl X, Ctrl V. Then lastly, we'll do this one, Ctrl X, Ctrl V. This is our parent tag. I don't think we even need it, but let's just complete it because we started this. Ctrl V. So now we are done with actually importing our components in the more optimized version where we are going to use our lazy load. So according to this, now we are going to have our suspense, then we'll have a fallback. So in case there's a delay in getting that page, we're going to show this loading ... Then our dynamic components will go here. So what I'm going to do now is this: everything that is in my routes, or I can make that here. So everything that is in my routes, Ctrl X, I'm going to wrap it inside a suspense. So Ctrl Shift space bar, so that we can automatically import that from React. So that has been imported. Then this is a self closing tag. This is a opening and closing tag. Then I need to add my fallback, then my div, loading ... So now I've saved this. So this is in line with what we have here. So we have our fallback equal to loading, then what we want to be lazy loaded will be inside this suspense. So now if I go to my browser, and it seems we have an error in the details. There is no dot. I know just the / means the home. So here's our details. Put a dot there. So that's the only error. Okay, it looks like we have some more errors. So I think this our routes needs to also be inside. React is telling us that the route should be a direct child of routes. so that was why it was found. So now we'll fix that. I think let's refresh. So we have that now. Now let me go back to the car page, the blog. So did you see that loading here? So let me refresh again. I think this our parent component prevented us from seeing the loading. So I think let's try that loading so that we can see it now that we are using Tailwind. So we can start that. So class flex center. I think we have that in our documentation here, in our index dot the CSS. We have flex center, yes, so we can use that now. So then we have that the mean height should be 70 VH. Then the text should be red, and the font should be Edu. So let's see how that looks like. So let's look at our page. So if I click on this now, you see that loading there. Then let's look at the text size. The text should be 3XL. So Alt Z to break that. So if I go back, I come here now. So we are already here. You will see the loading, and we have that. You see the blocks now. You see we have that. You see the login. You see the sign up. We have that card. So you see how it's lazy loading that. Now anyone it has loaded before, you notice the loading does not come there unless for some reason it's not able to get that. So let's refresh again just to enjoy it one more time. One more time. So let's refresh. So we have this now. So let's go back to our bottle. Notice we have that loading. The car, you see we have that loading. Now you see that it's taking much time to load this car component because of these images, and of course it only loaded this one. Then you come back here, we have this our list. So you see how we are gradually learning to optimize our React application. So you notice the speed has increased. So we have that loading, and we have that. Nice. So if you like, you can add a loading spinner there, but the height I added at 70 pixels makes it to sit more at the center because there's nothing to show, so it will sit at the center. Okay, so that is how we come to the end of this code splitting. Then this React fragment, we are already used to this React fragment. So React fragment are feature introduced in React 16.2 that allows you to group multiple elements together without adding an additional DOM method. This is particularly useful when you need to return multiple elements from a component render method. but you don't want to introduce unnecessary node elements that could affect the layout or style of your application. So you already have a CSS styling, but you want to add more things without changing anything in your CSS. So you can just use your fragments. We've already learned this in our rules for JSX. So the next one is make use of functions in UseState, and we've already used it severally. Remember in our account, yeah. So let's go back to our account. So I've been using it all this while. Yeah, if we go back if we go back to our use count, I think I can't find it from there, so let's look for it here in our custom hooks use count. So remember, that's what I'm using here. Good. So we've already done that. Then the next one is avoid inline styling. Of course, the same evil that the inline styling does in vanilla HTML, the same evil it does in React. So it doesn't help your React application to be fast the way you want it. So the last one, I guess, is the UseTransition. Yes, it's the UseTransition. So this UseTransition, the UseTransition hook in React plays a pivotal role in providing the performance, in improving the performance of application by allowing the marking of state update as non-blocking transition. This capability enables React to defer rendering for these updates, preventing UI blocking and enhancing overall responsiveness. So what this means is that if for some reason your application is handling some updates at the background and you're requesting for another update, using the UseTransition will give a feedback like the loading effect we just saw in our suspense. So the user will learn to wait that something is actually going on, that the website is not hanging but it's actually busy. So after a few seconds, when it is free, it will now load the update, so it will keep the user at ease. So that is what we want to do here. So to do that, we are going to go to our use count, then we are going to create the use count state is pending and start transition. Then you are going to update it using this format. So inside our increase count, for example, we'll then start transition, then we are going to set our SetState there. So that is what we want to do. Now you actually get to see this working if for some reason your application begins to hang for some reason, but if you optimize your page very well, I don't think it will show that, unless for some reason the network somehow makes the application slow and the requested update is dependent on network. So the user will get to see that something is actually going on the background, that the website has not is not hanging or is not responsive. So let's go back to our application. This is the last one for this video. So let is pending, then start transition. I hope I spelled that correctly. Transition, then equal to use transition. Okay, hit enter. So that will import automatically. Then the only thing we need to do now in this our improve count, Control X, we just put our start transition write our anonymous function, then inside it we'll paste our increase C. Then of course, to use this we need to send it out as is pending. So that is going to work now. So if I go back to my parent container, so remember we commented it out because it's making us not to enjoy the suspense. So I think we have an error. Suspense, why? Wow, good. Let's refresh. Okay, so we have this now. So as we update this count now, you see that we're not seeing anything. It's running fine. Sure, this page is optimized from what we have done so far, but let's now add one more in our parent container. So what I'm going to do here is the structure is pending. So if for any reason this pending is taking time, so what I'm going to do here is this is pending. If it is true, it should show in quotes updating. Else it should show our C. I think that is it. So let's save. So now from now on, once we are updating this C, notice if there's a delay. If you're noticing, I seen that flickering. So if there's a delay, notice that flickering, and that is, so if it is much, you see that updating will come to stay, so that you see now that there's no flickering, you see. So that is how we use I see the loading now. So the use transition. So you see, nice. And the block. So that is how we come to the end of this series. Now it will be wrong for you to be coding and you don't have an error. Well, it's not actually wrong, but sometimes I include this error in my videos just to show you that it is normal for you to have error when you're coding. But when you look at, if you look so closely, you won't have to go online in order to fix your errors. Maybe you just mistyped, or the way you arrange your code was not the right way, or you even fail to understand the React error that was showing you, either from your console or from the one that will pop up on your page. So please, the reason for this video is not just to show you how to optimize, but to make it to be part of your coding habit, so that whatever project you do will be a world-class optimized project. So in our next class on Saturday, you're going to learn how to optimize, more on optimization. So you're going to learn how to optimize our web assets like our images, minification and compression, where thankfully this is being done for us by React. So we have to place your images in React, saving images in Cloud. More optimization for us than using the production mode. So these are some of the things that we will learn in our next class. So see you in our next class. So thank you so far and happy practicing.